All right, so the integumentary system, let's see if we can get this going again here. Display. I don't know why this is the default, but. Okay, so the integumentary system, or integumentary system, some people call it, is, integumentary means covering, so it consists of the body covering that is the skin, which is your largest organ. The skin is an organ. Your hair, your nails, your sweat glands, and your oil glands. So we're going to talk about all the parts. We're going to see and label. We're going to explain some terms. So the first part is the physiology. Okay, how it all works together, the function of the integumentary system. All right. It has these following functions. Number one, it protects the body from injury. So fill out the blanks on your notes package. I will give you some credit for a completed notes package come unit exam time there. Protects the body from injury, okay? All of those work together to protect the body from any external force and chemicals, that kind of thing. Creates a barrier for microorganisms, okay? So it stops microorganisms from getting to your organs, so your inside organs, your heart, your lungs, creating infections in your flesh and that sort of thing. It also protects from harmful UV light from the sun. Now, your skin is amazing in that it allows some UV light to come in to make vitamin D in your skin, but it generally protects your body from the harmful UV radiation. Number four, it helps maintain an internal temperature of the body. So it helps maintain internal temperature. It allows your body to cool when you get overheated. It allows it to keep hot, keep warm when your body's cold. And it excretes waste through perspiration. So excretes means give off or exude. Ex is out. So excrete. Perspiration, that's sweating. Okay. And 6, serves as an important sense organ. If you get touched or you get burnt, if there's pain or there's something involved, it's important for your brain to know kind of what's happening to your body. All right, so hair, nails, even the hair in your head, the hair on your body helps with those finer sensations, okay? All right, so 3.2 is anatomy. So what are the names and positions and parts of the integumentary system? All right, so here's a bit of a chart. So your integumentary system consists mostly of your skin, okay? The largest part of that system is your skin. There are layers within the skin, if you look over here on the left. The epidermis, the dermis, and the hypodermis. Boys, while I'm talking, maybe just keep the side conversations to a minimum. If you have a question, please raise your hand, it'd be great. Hypodermis. So you all did that assignment, right? The tearing apart of the prefix, root words, suffixes. What does hypodermis mean? Who remembers?
No. Like beneath this. No. It's like two.
Okay, so what are the two parts? What are the two parts? Hypo and dermis. Yeah, two parts. So hypo is the prefix, dermis is the root. What does the dermis refer to? Skin, right? Yeah, first the skin. And hypo, I think you had it right, you said below, right. Hyper is above, hypo is below. Hypo, below. It rhymes. Okay. And epi, so epi is a prefix, it means outside of or above. Okay. Now, the other things that are part of the integumentary system, some are found rooted within the skin, I guess most of these are, glands, hair follicles, and hair itself, and the nails, toenails, fingernails, things like that. Okay. So hair is, on your arms, your eyelashes, your eyebrows, obviously hair on your head and different parts of your body as well. They all have pretty cool functions. We're designed pretty amazingly. So skin has 3 main layers, as we just talked about. The epidermis is the uppermost layer. The dermis is below the epidermis, and the hypodermis is below the skin layer, the lowest part of the skin. So we'll talk about the parts of the hypodermis. It's kind of like where's that boundary between your skin and your flesh, underlying flesh. Some of the parts kind of, they go through multiple layers. So it's kind of tough to know exactly where this ends, but we have 3 distinct parts that have 3 distinct functions. So we'll talk about those 3 anyways. All right, fun fact. Leather is made from the dermis of a cow. Anybody wearing leather today? Shoes, maybe? Coats? Leather? Tight black leather pants? Hunter?
Yeah.
Yeah. Okay. Yeah, so it's from cow skin, right? All right, skin. All right, let's talk about skin from superficial to deep. Let's see. Okay, epidermis. The outer layers made of the epithelial tissue. Okay, the epidermis is the outer layers. Now, there's a little bit of a memory mnemonic here, a bit of an acronym. Okay, that helps you remember some of these layers, and we'll see that in a bit. Okay, the first stratus, or the first layer, is the stratum corneum. Stratum corneum. Second is the stratum lucidum. Stratum granulosum. Okay, and then the words on the left can't getting, it'll make sense in a bit here. So corneum, lucidum, granulosum, spinosum. This was pronounced basal. I think some refer to as basal, but basali is how you pronounce that. So before we get out of the epidermis there, can't like getting sunburnt. Okay, your skin can't like getting sunburnt. It cannot like getting sunburnt, right? So that's a way you can remember these layers in order. C for corneum, L for lucidum, G for granulosum, S for spinosum, and B for basali. Your skin can't like getting sunburnt. Okay. The dermis, the next part down, that contains the glands and the nerve endings. The glands and the nerve endings. And finally, the hypodermis, and this was on your word assignment too, subcutaneous, right? Those three parts. So it's below the skin. So us is like pertaining to, sub, below, cutane, the skin. So this contains the blood vessels and the nerves. Technically not a part of the skin, but often spoke of in the system. So again, that line between where the skin ends and the flesh and the rest of the body kind of begin is a little fuzzy there. All right. So epidermis, dermis, hypodermis. You guys got that? Your skin can't like getting sunburnt. All right, that might help you remember some of those. So here's a bit of a diagram here. This is an extreme sort of zoomed in close up here. That doesn't even look like skin there, does it? Look at that. Some skin, maybe some hair in there. Okay, the different stratums. Now, again, that's just kind of about where they are. And some of the strata, the layers are a bit thicker than the others. But
the top of the skin?
Right here. That's the top of the skin there. Yeah. And your skin, like your skin cells die and fall off at the top, right? Like your skin actually, if you rub your hand like this, you'll be rubbing hundreds, if not thousands of particles of skin off. Cells, whatever. Like your skin replaces itself every, I don't know how many days it is, but yeah, it's the top layer dies off within weeks anyways, yeah.
It said 4 to 6 weeks.
Yeah. Yeah. That's a fun thought. Hi.
Why is it like red or purple or whatever?
Okay, why is it red or purple or whatever? Yeah, I mean,
I think that's just for
it's not, yeah, this is not necessarily the color of external skin there. I think it's just maybe been dyed to see the layers or colored to differentiate between the layers. If it was all the same color, it'd be tough to see the layers maybe, but it's a good question. Yeah. And also like flesh itself, when you zoom in, is a lot of blood vessels, right? There's a lot of blood in the skin. So when you zoom in incredibly, you get to see more of the blood too. Yep. Mike?
Wait, so how thick would like the epidermis actually be?
Good question. It's just millimeters. Like it's millimeters.
thinner than a piece of paper on it said
All right. So just maybe put that. Just close it up for now. Okay. You can look afterwards. Make little notes. Okay. I don't want you guys on your computers while we're doing the notes. Not just now. Please make little notes if you want to look something up later. Appreciate that. Okay. Just so we can all stay focused. Alrighty. Fun fact: 95% of human skin cells are keratinocytes. So you should notice or recognize, oops, I didn't mean to do that. You should recognize this, the protein called keratin. Keratin, that's what your hair is made of. So the skin cells are the majority of skin cells are keratinocytes, which produce keratins, as protein. 10% of the stratum basale are melanocytes, which produce the protein called melanin, and you've probably heard of that before. The melanin is a dark pigment that leaves the melanocytes. It enters the keratinocytes and surrounds the nucleus to protect against UV rays from the sun. So when you are out in the sun and you are exposed to a lot of sun and you tan, then when you get darker, that's more melanin being produced. And some of us, some that have darker skin normally, have a higher production of melanin. It's just a dark pigment. People that have more fair skin, lighter skin, don't have a lot of melanin being produced. Some that are darker skin, lots of melanin being produced. Okay?
People who don't tan and they just sunburn, is that just because they don't?
People that don't tan, yeah, it's just, I guess, I don't know exactly what the deal is there, but the melanocytes don't produce as much melanin, I guess, to protect. So that's why people that don't tan, sometimes they just go straight from white to red, burn. So there's not a lot of protection there. The number of melanocytes in a human is approximately the same. No matter the skin color. So darker skinned people do not have more melanocytes. It's just the amount of melanin that's produced. So we're all about the same, have about the same number of melanocytes. It's just the amount of melanin that's produced. Okay, yeah, question?
I don't understand that. Can you explain?
You don't understand what the last point there? So it's not the number of melanocytes, that's the location of what produces the melanin. It's not like that darker skinned people have more melanocytes, more sites that produce the chemical. It's that there's just more chemical produced in the skin. Yeah.
So wait, we have more melanocytes?
No, more melanin.
Oh, more melanin.
Not more melanocytes. It's roughly the same, but just that you like darker skinned people like yourself produce more melanin, so it's darker. Your skin looks darker in general. Okay?
Yeah.
Got it? Very
It's
good.
an advantage, not a disadvantage.
That's a big advantage. Yes. Sure. Yes. Yeah. Attaboy. Good job. Yes. Good job. Good job for you. All right. Eccrine. Okay. Glands of the skin. Eccrine. The eccrine glands. They secrete straight out of the skin surface to remove waste and to cool the body. Okay. Eccrine is odorless. Okay. Apocrine. Apocrine, connected to hair follicles in the armpits and the groin, do not function until after puberty, to be released during sexual excitement. It's odorless until bacteria decomposes in it. Then this causes odor. So this is, like I say, specifically connected to the hair follicles. Obviously, as a cooling mechanism too, this would be part of it. The eccrine is mainly what cools. So when you sweat, okay, the sweat itself doesn't stink. It's the bacteria that decomposes in the sweat. So if you sweat and you don't do anything about it, then you're going to stink. You're going to smell, because that's the bacteria that's decomposing in there. If you have, deodorant or antiperspirant or something like that that counteracts the decomposing bacteria, that's when your armpits won't smell so bad. Okay, so yeah. However, whatever you need to do to make sure that you don't smell that bad, please do that. Just for the sake of the air quality in this room. You guys are pretty good though. Yeah. Middle years kids, oof, they have no idea what's going on with their body. They don't know how to deal with it. Remember those years? Yeah. Okay. I'm glad I don't teach middle years anymore. What's that?
They had to put a fan outside the boys' bathroom when we were in middle school. Let them
Yes,
do the fan.
there'll be lots of filters and fans down in the middle years swing, I'm sure. All right, but hey, we were all there at one point. Okay, this is, anybody know how to say this word? Any guesses? Sebaceous is correct, sebaceous, yeah. So the sebaceous glands secrete an oil called sebum next to the hair follicle, protects against bacteria, fungi, and softens the skin. So 3 types of glands: eccrine, apocrine, and sebaceous. All right, here's another fun fact. Earwax is secreted from the ceruminous gland. I think I'm saying that right. Ceruminous gland. That's the fourth type of gland in the human skin. So earwax, deep inside your ear, that also is produced to take away dust particles and different bacteria that gets inside your ear canal. So your earwax is supposed to kind of take things away out of your inner ear, because you're quite susceptible to infection in your inner ear. So earwax is pretty important for that. All right, here's a little bit of a diagram. I will pause on this for a few minutes to let you take a look at this. If you want to sketch this out, this is not in your notes. If you want to sketch this out, you can. Just a rough sketch. But let me just tell you what this sketch is saying. So the hair follicle, okay, is here underneath the skin. The apocrine sweat glands are right here connected to the hair follicle, okay? The eccrine sweat glands are near the hair follicle, but they're not connected to it per se, okay? The sebaceous gland is also connected to the hair follicle. So apocrine sweat glands, the sebaceous glands that produce the oil for protection against infection and stuff. And then this is straight cooling right here, okay? So sweat glands from your hair or from not from your hair all cools the body. But that's sort of what it looks like, okay? All right. I'll go back later. I'll go back later if you're not done. Yeah, I can go back later for the diagrams, guys. Just leave some space. Nerve endings. So nerve endings in the skin detect temperature. They also detect touch or pain. So nerve endings in the skin, very, very important. If you didn't sense any pain, or if your body could not sense what temperature it was outside of your skin, you would have a tough time regulating your internal body temperature. You'd also have a tough time keeping yourself away from, safe, away from harm. So if something is hot, you accidentally touch something that's hot, your skin will know right away, and your body will send messages to your brain to get out of there. Pain is not the enemy. The effects, what's happening to cause the pain is sort of the enemy to your body. So nerve endings in your skin are very important. And yeah, like if you have any kind of injury and you're sore in that area, for the most part, that's a signal to your brain to say, I need to take care of this part. It's healing right now. There's some trauma. So nerve endings, to sense the things around you, that kind of thing.
Can you kill it, like the nerve endings?
Yes, nerve endings can be damaged for sure through different things, different trauma, burns, that kind of thing. If you're in a car accident or something and people lose parts of their skin or lose parts of their of that, then those nerve endings could be damaged or gone. So yeah. Okay, I can't hear, guys. Hang on. Say again.
Like when you constantly do yourself in certain places, like for example, like mothers back home, they often touch hot spots and stuff. So I'm used to it and they don't.
Sure. Okay. Yeah. So that's a bit of a side story. Yeah. If you're used to touching hot things, then it doesn't bother you after a while. Probably you've damaged some nerve endings, so it's not bothering you. I mean, probably if you don't have the sensation, then something is probably malfunctioning, I would say, especially if it's due to repeated exposure of things like that.
Pain is an illusion,
Huh?
For me, pain is an illusion.
Okay. Pain is an illusion. Sure. You're a tough guy. I get it. All right. So the nerve endings can reach as high as the stratum granulosum in the epidermis. So it can be very close to the skin, and the more sensitive the parts of your body are, the nerve endings are closer to the surface. So here's a little bit of a diagram here as well. A lot of this is the same as the other one, I guess, here. This is, very much the same. So your hair, some of it's above the surface of your skin, some of it's below. There is a root. So if you pluck hairs out of your body for whatever reason, you could break off the hair, near the surface. You could pull it out right by the root, which makes it difficult for it to grow back again, but that may be the purpose. Anyways, you have glands attached to the hair underneath the surface as well. So hair is not made of cells. This might be a new news to you. I'm not sure. Hair is not made of cells per se, but protein that cells produce. The protein is something called keratin. So we talked about keratin earlier. But hair is actually a protein. So it's some people say it's like dead cells. It's not really a cell. It's a protein that is sort of compacted and protrudes from your skin.
So is it wasted?
Is it what?
Is it like wasted protein or just?
Is it wasted protein? Well, I wouldn't say that hair is wasted. No, hair has a purpose. It's not necessarily waste, and it's not necessarily it's your body produces this sort of protein to produce hair and fingernails as well, which you'll find out.
So like if you eat more protein, does that mean your hair will?
No, not
Or is it, like,
necessarily. No, if you eat more protein, you have more hair. Not necessarily. No, I would be eating lots of protein so I could grow more hair up here if I was. No, it's not necessarily the same proteins you get from foods. It's a different kind of protein that's made. But that's a good question. And there may be some connection with certain proteins that you eat and hair production, but I don't know that. Could be. Yeah.
So what makes someone
Go bald?
Yes.
No hair.
I know like
It would be different hormones and different chemicals and different oil, like the gland function and all sorts of things.
Also,
Yeah.
like the root gets injured.
Oh yeah, if the root gets injured or any part of the actual system that grows hair gets injured, but yeah, I don't know if that's what he meant, but like male pattern baldness would be a combination of things, genetics as well. But okay, these are good questions. Shh. Hey guys, listen. Yeah, folks, listen. These are good questions you should be writing down. I don't have all the answers. I don't have great answers for a lot of your questions. I would have just surface level answers. So you should write these questions down and research them later. Not right now while we're talking about this stuff, but write the questions down. You absolutely should be having some of your own questions that you research. Okay, that's how you learn things. Your interest-based inquiry and curiosity really accelerates your learning. So yes, male pattern baldness, or how can we grow more hair, or what is that connected to? You'll find out here. I think it's even in this slide that why you have curly hair versus non-curly hair, right? Some of you have poker straight hair, some of you have really curly hair. So all this kind of stuff, if you don't get answers to this stuff, this is stuff you should be researching on your own. Okay, let's keep going though. The shaft of the hair is said to be the part of the hair that's above the skin, and the root is below. Okay? So the hair shaft is above the skin, and the root is below. The shape of the follicle, okay, this is one of the things, I've heard there are others, but the shape of the follicle, so right here, determines if your hair comes out curly or straight. That's one of the reasons. I've also heard that it's the amount of sulfur that's in your hair that causes that as well, so it could be chemically based. But the shape of your follicle, you can kind of probably understand that, hey, if the shape of your follicle is sort of like curvy or spiral, then your hair kind of comes out that way, and then it kind of like, curls around like that, and you might end up with curly hair. So what causes that shape is another story, but if the follicle, your hair follicle, the shape of that determines whether you have really straight or curly hair. It's interesting. The amount of melanin determines the pigment of your hair. So darker hair has more melanin, and so on. Light hair, not a lot of melanin. Okay, similar to your skin. Okay, any questions about hair? Yep.
How does sun bleaching work? Like when you stand outside?
Yeah. How does sun bleaching work? Well, the UV rays and the radiation basically affect the outer layers of your skin and discolors. Yeah.
Basically, the melanin kind of just overloads because it basically enters the melanin in your hair, and then it becomes lighter because the melanin is actually.
Yeah.
That's what it is, or something close to that.
Yeah, could be. Yeah.
Like, how do some people have very fair skin but very dark hair? Because like it's both produced by melanin, right?
Yeah. I mean, part of it is, melanin is what produces darker skin and darker hair. If you really think about it, there's not a lot of people that have really, really super light skin and really, really dark hair. Not a lot. Like that's not a typical combination for sure. But obviously the melanin is produced pretty close to the hair follicle there, separate from the the skin layer. So I guess it could be that, but they don't come all from the same place. Okay, let's talk about nails. Everybody pay attention, please. Back up here. Okay, nails. Here's a bit of a diagram here. Fingernail. Your nail plate is sort of the large, sort of flat part of your nail. The nail groove is the side where your nail kind of sort of ducks into your skin there. The lunula is this sort of half moon. I think this is the cuticle. We'll see in a second. And this is the cuticle, I think. Eponychium. This is the eponychium, is how you pronounce that. So the eponychium here, I think that is what your cuticle is, but we'll see in a second. So nail plate, nail groove, lunula, eponychium. Nails are made of keratin as well as hair, and act, the hair is made of keratin as well as the nails are made of keratin. Nails are not made of hair. Kind of. Acts as a protective covering for the dorsal side of the distal finger and toe bones. So literally your nails are there to protect the ends of your fingers. You didn't have nails, impact like this would actually have a lot more damage on the end of your fingers and toes. So that's kind of cool. And protection for the end of your fingers and toes. The whitish half moon at the base of the nail is called the lunula. The cuticle, eponychium, is the narrow amount of dermis surrounding the nail. So, yeah, the half moon kind of part here in your nail, that's the base of the nail called the lunula. And the skin that kind of like is the interface between your nail and the rest of your skin there, that's the cuticle, the eponychium. Questions? All right, let's keep going with disorders and diseases, 3.3. All right. Lesions. Okay, so you've heard of lesions before. Lesions are tissues that are altered because of a disease or disorder. So you'll see lesions on the skin, on the integumentary system. And you won't have to memorize all these different shapes, but just for interest's sake, they're just listed in your notes. Like I say, you don't really have to memorize exactly what they look like. Examples of lesions include macule, papule, nodule, vesicule, bulla, the pustule, the wheal, the tumor, the ulcer, and the fissure. So different kinds of skin imperfections or lesions, different sizes, shapes, depths. They have a little bit different names. The focus is not, right now we're not focused on too closely on each one of these, but the macule is the smallest one, and looks like the bulla maybe is the bigger one. An ulcer, you hear of ulcers a lot in the stomach, lining of the stomach. That's where it's most common that you hear about ulcers. A fissure is like a split. So if your skin really splits, it's I don't see it on here, the fissure, the ulcer, but.
I don't think those two have a specific shape though.
No, they're not a specific shape. I think this is maybe more the type. Yeah. Okay, microorganisms, infections. You guys find that on your notes there? Everybody with us, right? Okay, make sure you're filling in your blanks here. Any disease caused by an external bacteria or microorganisms or a virus is called an infection. There are many, but some of the more common ones are, rubella. Rubella poses a severe threat to unborn children, causing severe birth defects. And the only place you've probably heard of rubella is in vaccinations, measles, mumps, rubella. If you guys ever heard of that? That's a typical vaccine that's given to very young children, and it protects against rubella is one of them. So immunization, that's very important. Chicken pox is another one. There's a picture there. I don't know if any of you have suffered from chicken pox when you were younger, but chicken pox and shingles Both have vaccines, and both diseases can cause birth defects if pregnant mothers are exposed. And also, yeah, you can catch chickenpox after you're born as well, obviously. Did you guys get all that? There's only one point there. Measles. So chickenpox are kind of like larger, darker spots that are a little bit more spread out. Measles are kind of like, well, kind of that picture there kind of gives you an indication. It's kind of like more of a whole skin rash, almost. Measles were nearly eradicated. They are making a bit of a comeback now. There's fewer people getting vaccines. So it is coming back a little bit. It is highly contagious and causes a severe rash across the entire body. Fever and loss of body fluids also are side effects. It can be fatal, especially to very young children. So again, you may have heard of these skin diseases as it pertains to vaccinations. Because I think the measles, mumps, rubella is a combined vaccine that young children get. I think there's several doses, I think, even of that, different ages that young kids get to protect them, help their body fight against these diseases. All right, cancer. You've all heard of cancer. Unfortunately, cancer is when body cells start to grow out of control. This uses up the body's energy and it can displace healthy cells. So it's not just healthy cells growing out of control. It's not like you're getting bigger. Oh, I got cancer, I'm growing. No. It's not like regular healthy body cells. It's body cells that aren't functioning properly, and they're lots of times they lose function. They're like mutant cells, okay, that often suck up a lot of the body's energy. They can, like it says, displace and overtake an area. If you have a real large clump of these dysfunctional kind of mutant cells that reproduce uncontrollably, that clump becomes what we call a tumor, right? So you've heard of all this kind of thing. So cancer is fast-growing, dysfunctional mutant cells that can start. It can start for various reasons in different places of your body. Some can be fairly contained. Some spread quite easily. Some can be. Some forms can be fairly manageable. Some, again, can be fatal very quickly. There are 3 types of skin cancer, so we'll talk about skin cancer because we're talking about the integumentary system. The basal cell cancer, I'd like to cancel cancer. But basal cell cancer is the bottom layer of the epidermis. That's where that cancerous growth starts. Squamous cell cancers, that's the top layer of the epidermis. And again, I don't know a whole lot about each of these types of cancers. This is just the location of them. Melanocyte cancers, I believe this is melanoma. That's what they call the melanocyte type cancers. That's the pigment cells of the epidermis. This one's responsible for more than 75% of the deaths from skin cancer, and it often spreads to other organs. Again, your skin is a large organ, and it's obviously very connected. Your skin covers your whole body. So if you get, if there's cancer that starts in your skin, it's obviously connected to all parts of your body. So it can spread. But I think this melanocyte cancers is also what they call like melanoma is the main type of that melanocyte cancer. But don't quote me. But I think that's what that is. Any questions? Yeah. I'm sure all of us have been touched by cancer. We know somebody maybe close to us or maybe maybe friend of the family or whatever that's been affected by it. So it certainly is a big thing, and certainly a lot of care and sensitivity related to this disease. Yes? You can. Okay, we're going to talk about burns now. So yeah, make it quick so we don't miss too much. Burns are the second leading cause of accidental death in North America. The second leading cause of accidental death in North America. A burn is an injury caused by heat, electricity, chemical, friction, or radiation. So again, any kind of like friction burn, like a road rash or something, like can actually behave like a burn. If you get electrocuted or that kind of thing, that causes a burn. If you get some really rank acid spilled on you, that causes a chemical burn, that kind of thing. Most people know about 3 degrees of burns, but there are actually 4, so we'll talk about each of those. you get that? There's only one blank there for you. Okay, first degree burns. Again, this is stuff you've learned before in science classes in earlier grades, I'm sure. First degree burns, they just affect only the epidermis. So they're surface burns. Sunburns are included in first degree burns. There's redness. There's some minor pain. Sometimes the skin dries out and peels away, so most sunburns. Sometimes if you get scalded by hot water or hot, a hot liquid, that can cause a first degree burn. So it's just the redness surface layer of your skin. Red, yeah, your skin gets red if you have a first degree burn. It doesn't penetrate deep into the lower layers of the skin, but it's just on the surface. A sunburn is a common one.
Someone is very, very angry. Yeah, face turns red.
Okay, so if someone's very angry and their face turns red, that's not a burn. That's more like blood is rushing from inside your body to the surface of the skin. And so, like that kind of thing. And when you work out and things like that, there's a lot more blood passing through your body, and the blood actually kind of gets forced to the very outer layers of your skin to kind of cool the skin and stuff like that. So yeah, it's that redness is not necessarily a burn, but that's a great question. It's a great question. Yep.
I don't get red.
You don't get red? Well, you do, but maybe it's not as noticeable. Yeah.
I don't.
Okay, that's good. Second degree burns. Second degree burns affect the dermis, not just the epidermis, but the second layer of the skin. Second degree burns, you'll see that there's redness and pain and swelling there as well. Often looks moist, and blistery. Blisters may develop and cause scars, so this could actually cause scars on your skin because it does affect the lower layers of your skin.
This happens to me one month ago.
Say again?
This happens to me 1 month ago. Boys gone.
Yeah, great.
Blisters, not all blisters are second degree burns, boys. Not all blisters are second degree burns. Is that what you mean? You had a blister but it's gone? Yeah, that's not necessarily a burn. So if it's from heat and you get burnt by an open flame or something, then if you have a second degree burn that penetrates to the lower layers of your skin, it will often be accompanied by blisters, okay? But if you're playing baseball or something, or if you are working, you're shoveling or something, and you get a blister in your hand or something, that's not necessarily a burn. The friction, but that's not quite the same. Okay, is that what you're talking about?
No, on this picture, it happens.
The picture, yeah.
Yes,
That's a blister. That's called a blister. Yeah. Which may result from a second degree burn. Okay? Okay. Third degree burns. Third degree burns reach into the hypodermis. Boys, pay attention, please. Third degree burns reach into the hypodermis. So this third degree, third layer, right? First degree, first layer. Second degree, second layer. Third degree, third layer. Bit of a pattern there. The skin appears stiff, waxy, white, leathery, or even tan color. It often damages nerve cells and makes the area feel numb. This will cause scars. And this diagram on the right just gives you a quick sort of show of, first degree burn would be redness in the surface only. Second degree would reach that lower layer, it would cause some more significant damage. The third degree is like a burning of your flesh, right? Or the below the surface of the skin kind of thing. Now, fourth degree burns, not very common, but if you have a burn that penetrates all the way to the muscle layer or even the bone layer, that would be a fourth degree burn, okay? So muscle or bone layer. And sometimes it's tough to tell what's the third layer and what's the muscle layer, but certainly if it gets down to the bone, that's a fourth layer. So skin is blackened and charred. Usually at this point though, if you get burned all the way down to your bone, you won't feel much pain there because all the nerves are destroyed. So there's nothing to send pain messages to your brain if you've destroyed all the nerves. So obviously there will be some pain related to that and to the recovery and all that sort of stuff. But it's not like if you get a 4th degree burn somehow, it's not like it will feel the same as some of the other ones where your nerves are intact. Other than the obvious burn, some other things that will happen to the burn victim is a drop in blood pressure due to blood loss. So yeah, if you get burned all the way down to your bone, you're going to be losing blood, and there'll be lots of things that connected with that. But that's what a 4th degree burn is. Yeah. When Josh gets back, I guess.
So is that basically
Also, oh, sorry, question?
is that basically what Anakin Skywalker is suffered?
Oh, maybe. Yeah, maybe. Yeah, that could be it. Also, often increase in heart rate as the heart tries to pump blood faster around the body to make up for the lost blood. And if there's significant parts of your circulatory system missing, well, your heart's going to go out of control there. All right? So any questions about that? Any questions you wrote down on your notes that you were wanting to ask, or concerned something that you didn't see?
Is a 4th degree burns treatable?
Well, 4th degree burns, are they treatable? Everything is treatable that happens to your body unless it results in death. But it would
Difficult.
It would include significant reconstruction. Yeah. Yes.
Can 1st degree burns cause scarring? Because it didn't say.
Yeah, usually not. Usually not. It's the 2nd degree burns that penetrate that first layer. Those are the ones that can cause the scarring. Because when the skin, guys, remember when I'm talking, you're not, right? Like you're literally not talking when I'm talking. It's easy to remember, okay? All right. So yeah, usually the 1st degree burns is just the surface layer. It's kind of like the layer of skin that falls off anyways and naturally replenishes. So yeah, usually it's not scarring from 1st degree. If it does scar, that probably means it's penetrated into that lower layer. Probably means that it's not 1st degree anymore if you do get scarring from it. But yeah.
So wait, you're saying that what if a 2nd degree, do you get scarred from 1st degree?
That's exactly what we're saying.
Definitely get scarred. Like,
That's what we're saying. Yeah.
If no matter.
Yeah, I mean, I can't say every situation that 2nd degree burns would leave scarring, but you've penetrated so your skin has to repair itself. So when you have like a natural covering of skin and something happens that you take away part of that skin, your skin has to fill itself in. That's kind of what a scar is. If you've penetrated the layer, when it heals and fills in the missing piece or the split, right? Like that's when you get a scar, because the skin that is replacing the skin that was lost or damaged, it doesn't look exactly like the other skin. It's still skin, but if it goes deep enough, if your body has to repair that spot, then your skin will probably not look identical to the skin that's been around for longer and has the same sort of natural over time structure. Does that make sense? So I can't say that every 2nd degree burn is going to give you some noticeable scar. I can't say that, but when enough of the skin has been damaged and needs to be replaced, that's when you see a scar. Okay?
3 and the 4s will definitely cause scar, right?